Alright guys, today we're going to take a look at how to solve inequalities that contain absolute values. So what we're going to do is we're going to basically be combining our knowledge of inequalities that we've been working on so far, especially compound inequalities, and combining those with our knowledge of absolute values. So before we do that, I want to see if you remember how to do a problem like this. The absolute value of 2x plus 1 equals 5. See if you remember how to solve that. Try solving that. Maybe you can solve it on the back of the note sheet or something like that. Pause and then come back. Okay, so I'm assuming you've done that by now. And if we remember right, what this really means is that whatever is inside the absolute value could be equal to 5, or it could be equal to negative 5, because when you take the absolute value of negative 5, you get a positive 5. If we solve each of these, when we solve this one, we get x equals 2. When we solve this one, we get x equals negative 3. Okay, so there's this issue with absolute values turning negatives into positives. Okay, so what I want you to think about now is this. In your mind, what do each of these absolute values mean? So like if you had to describe the values of x to someone else here, how would you describe in your own words what each of these absolute value inequalities means? Think about that for a second, pause, and then come back. Okay, so if the absolute value of x is less than 4, to me what that means is that if I ignore the sign, the number's got to be smaller than 4. Or if I put that a different way, x has got to be between negative 4 and 4, right? Because as long as it doesn't get on the other side of negative 4 or the other side of 4, if it stays between those two numbers, when I take the absolute value, it'll be smaller than that. The problem is when I get beyond negative 4 to like negative 5, negative 5 is smaller than 4, but when I take the absolute value of that, 5 is no longer smaller than 4. If I were to write that as a compound inequality, it would look like this. X is less than 4, greater than negative 4. It would be an and inequality, okay? Okay, both things would have to be true. It's got to be between both those numbers. Absolute value of x is greater than 4 is the opposite of that. X can be anything but numbers that are between 4 and negative 4, or negative 4 and 4. Okay, so it's basically got to be anything other than that. So for here, the number could be greater than 4. Okay, like any number that's greater than 4 will work, or it could be any number that is less than negative 4. So it's either got to be smaller or it's got to be lower, further left on the number line than negative 4, or bigger or further right on the number line than positive 4. It's basically the exact opposite of this one. You see, whereas this one was between those two, this one is anything but between those two. And this one was an or inequality. One or the other had to be true. Okay, so here's what I want you to do. Take each of these next inequalities that you're going to see here. There's 4 of them. What I want you to do is transform them into one that does not have an absolute value. Okay, rewrite it as one that does not have an absolute value in it at all. Okay, so pause and then come back. Okay, so this one, 2x plus 1 is less than 5 and greater than negative 5. So whatever's in here has to be between 5 and negative 5. This next one's a greater than or equal to 1. So it's not a between, okay? Because if the absolute value has to be bigger, it's got to be everything but the stuff that's in between. So it's either greater than or equal to 12 or less than or equal to negative 12. Okay? C is very much the same thing. It's either greater than 6 or it's less than negative 6. And the last one is another one that is in between. It's less than or equal to 3 and greater than or equal to negative 3. Those less than inequalities turn into nice and compound inequalities, that little one that looks like kind of like a sandwich, you're sandwiching stuff in the middle, and the greater than ones turn into ors. Okay, lastly, here's what I want you to do. What you're going to do now is do exactly what you're doing above, transform it, but then I actually want you to finish it, completely solve the inequality, and then I actually want you to make a graph of the answer. Okay, so all we're going to do is transform, and then you already know how to solve compound inequalities. We did that last. So transform it, solve it, and then graph the solution set. Do that for both of these, pause, and then come back. B is a little tricky. Okay, so for this one, I'd start with 3 minus x is greater than 15, or 3 minus x is less than negative 15. When I solve these for x by subtracting 3 from both sides, my problem is that I get a negative x. So now I got to divide by negative 1, and I get x is less than negative 12, or x is greater than 18. So what that basically means is x is going to be everything but the values that are in between negative 12 and 18. Okay, so if I make a number line of that, I put open circles on negative 12 and 18, and I shade to the outside. Okay. For this last one, the problem that we have is, this is very similar to some other absolute value problems that we did. We can't transform the absolute value until we get rid of that 5. Okay, we don't have an absolute value by itself first. So I'm going to divide both sides by 5 first, and I'm going to get absolute value of x minus 2 is less than 9. Now I can transform the absolute value. Now that's okay to do. So I get x minus 2 is both less than 9 and greater than negative 9. It's between those two. Add 2 to all 3 sides of the inequality, and I get that x needs to be between 11 and negative 7. Draw a number line. And this time I'm making open circles still, but I'm shading in between. Okay, that's it for that's it for inequalities with absolute values. Again, the big thing to remember is that those less than inequalities turn into and compound inequalities. The greater than ones turn into ors.